Hello guys, welcome back to our channel Career at Market Value. So the topic of today's discussion would be stationarity test, arch test and generation of residuals. So everything will be done in eView software. So for that I'll simply copy the path first and open my eViews page. So this is how a standard eViews looks like. So I will export my data over here. So you need to click on file, then open, and from the drop down click foreign data as work file. So there you paste your path and select your data, the data file, and click on next. Just be sure that eViews doesn't give you NA or null values for the columns that is of our interest. Here it's date, price and returns. This should not be NA. This shouldn't be NA. So I click on next. Okay, so date, price and returns, there isn't any NA. The top data is NA since the returns is not generated. So it's okay. Now I have to click finish. Okay, so first thing that we will do is we'll test the stationarity for our dataset. So stationarity testing is simply by clicking on my series of data, which is the returns. We'll be testing our stationarity test on returns. So I'll click on that. So this is my returns data. Now I will perform an unit root test, which is simply the alias for stationarity testing. So I'll click on view, click on unit root test. So you can see it's augmented decay fuller or the ADF test. So the test for unit root is in level 1. You can specify your first difference or second difference, but by default it is at level. Include in test equation, intercept will be included in test equation by default, and this is SIC criterion. You can also choose AIC criterion if you want to. So SIC is good enough. Maximum lags is calculated by eViews by itself. So here it is 31. So let's check the ADF test, the result of that. I'll click on OK. So here my augmented decay fuller test is done. So you can see the probability is significant. I mean, we can reject the null hypothesis. You can see the null hypothesis over here, returns as a unit root. So since the probability is significant, we can reject the null hypothesis and state that our data is stationary. And also you can see the Derby-Knudsen test statistic is 2, which is good. It should be closer to the value of 2, so it's good. So we can confirm that our data is stationary. So now the second thing that we will be picking up is generating residuals. So why we will be generating residuals? I mean, it will be needed for estimating the Garch equation. So that's why we will be needing to generate the residuals. So to generate the residuals, first of all, we have to estimate an equation. I will simply click on quick, estimate equation and type over here returns space C. So I am running an least square regression model NLS ARMA on the returns on itself. I mean, I am estimating an equation on the return series, and let's see what it gives. So this is what it has calculated. I'll forecast my returns, and the forecast name is returns F, that is the forecasted returns, and I'll click on OK. So my returns is forecasted, and you can also see one more series is generated over here, that is returns F. Now I will need the value of residuals. So residuals are simply the difference between the estimated regression equation, the values from it, and the actual values. The difference between them will be the residuals. So you can see the residuals over here. Actual is this, and the residual is this. Sorry, the fitted one is this. Now I need to see the residuals that is generated. So if I click on reset, now the residuals are properly generated, and these are the values. I will simply go ahead and copy this entire series, and when you click on copy, it will ask for formatted or unformatted. Click on formatted and click OK. Now we will go and paste this data on the dummy data Excel sheet that we have. I'll paste this over here. Simply Control V. My data is pasted. I'll delete the NA. So these are my residuals. Now what is the use of these residuals and why I have generated this? I'll discuss this in my next video, where I'll be finally estimating the Garch equation. So I'll again roll back to my eViews data screen. I'll minimize this. Okay. Now we need to test arch effects for our returns data, so that we could confirm that whether our returns data actually have the heteroskedastic effects or not, or they have the variance in the errors is inconsistent over time or not. We need to test that. I mean, to do the arch test, first of all we need to open our test that we are I mean the regression that we did. We have to open that. I think I have closed that box, so no issues. I'll again conduct the regression, so that will simply be click on quick estimate equation, just write return C over here, and you can see my regression equation, the ARMA equation is over here. Now if you need to test the heteroskedasticity effect for your data, you need to click on view. You can see residual diagnostics and the drop down heteroskedasticity test. You simply need to click on that. It says Brosh, Pagan, Godfrey, Harvey, Arch, White, everything is there. So we will select Arch, number of lag 1, that is by default, so let it be, and click on OK. So that is how the arch test is conducted, and this table is generated. and we can see our probability estimate for f and chi-square is significant. Same thing for the coefficient and the residual, that probability estimates are significant. The Durbin-Watson test statistics is also good enough, close to 2. So because of this, the test results, since the significance level is met, or it is significant, so we can reject the null hypothesis. The null hypothesis here is the series contains homoskedastic effects. So the null hypothesis is rejected, which means the series don't have homoskedastic effect. So we can alternatively say that our series has heteroskedastic effects. So that is how heteroskedastic test is performed. So now we are sure of two things, that our data is stationary and our data have heteroskedastic effects. So now we can go ahead and conduct the heteroskedastic models, modeling through the heteroskedastic methods of our data. So those things will be for our next video, where I will estimate the Garch equation and show you a full model building process. Till that time, that's all from my side, guys, and do share, like and comment on this video